Hi, my name is Tawfiq Omar, math teacher. In this video, I will explain Chapter 1, Function and their graphs, Lesson 3, Part G, Domain and the range of a logarithmic and the exponential function. Domain and the range of exponential function. The basic formula of exponential function is fx equal e to the power x. If we draw the graph of this function is like this, which intersect with the y-axis at 0, 1. Because the graph of e of x is over x-axis, therefore e of x is bigger than 0, which means positive for all x. And if we have a function fx equal to e to the power gx, which means if the power is another function, domain is all real number and range is from 0 to the positive infinity. E of x not equal to 0. F of 0 is equal 1. Domain of e to the power gx for all real number x is domain of g of x. Example number 1. Find domain of the function fx equal e to the power sine x. Since the domain of sine x is all real number, therefore the domain of function fx equal e to the power e sine x is R2. As you can see in the graph of the function, we can find the range by using the range of sine, which the range of sine is from -1 to 1, and then in place of sine x write -1 and 1, you get that the value of y is between 0.37 and 2.72, which means it is a range of the function fx equal e to the power sine x. Example number 2. Find the domain of the function fx equal e to the power's absolute value x plus 1. Since the domain of absolute value x plus 1 equal to real number, therefore the domain of function fx is equal to the real number. Example number 3. Find the domain of the function fx equal e to the power 1 over x. Since the domain of 1 over x is equal all real number except 0, that means the domain of function fx is equal, therefore domain of fx is R except 0. And the graph of the function is showing that the range is from 0 to 1 and then from 1 to the positive infinity. Example number 4. Find the domain of the function fx equal e to the power 1 over x squared minus 1. Since the domain of 1 over x squared minus 1 is equal all real number except -1 and 1, we take before how we can find the domain of a rational function by taking denominator equal to 0, which means x squared minus 1 is equal to 0. Then taking 1 from left to the right, then x squared is equal 1. By taking square root of both sides, then x is equal plus or minus 1. That means all real number except -1 and 1. Therefore, the domain of the function fx is equal e to the power 1 over x squared minus 1 is all real number except -1 and 1. All real number except -1 and 1. Example number 5. Find the domain of the function fx equal e to the power tangent x. Since the domain of tangent x is all real number x when x is not equal to pi over 2 plus n pi when a is integer. Therefore, the domain of the function fx is all x when x is not equal pi over 2 plus n pi when n is an integer. Because e of tangent x is not equal to 0, therefore the range is from 0 to the positive infinity. Example number 6. Find the domain of function fx equal e to the power square root of 2x minus 4. First of all, finding the domain of the square root 2x minus 4 is 2 to the positive infinity. We take before that how we find the domain of the square root, taking under the square root 2x minus 4 is bigger or equal to 0. By taking minus 4 from left to the right, then 2x is bigger or equal to 4. By dividing by 2, therefore x is bigger or equal than 2. That means the domain of square root 2x minus 4 is from 2 to the positive infinity. Therefore, the domain of function fx is from 2 to the positive infinity. From 2 to the positive infinity. Domain and the range of logarithmic function. The basic formula of logarithmic function is fx equal ln of x. Its graph is like this. Therefore, the domain is from 0 to the positive infinity. Open interval. And the range is all real number. If we have a function with the ln for the function gx, that means domain of this function, ln of a function, is all real number when this function is bigger than 0. When this function is bigger than 0, which means fx equal ln of gx, then all real number x when gx is bigger than 0. As we take f of minus 5 equal ln of minus 5, and f of 0 is equal ln of 0 are not undefined. But f of 1 is ln of 1, which equal 0. Be careful. Ln of e to the power gx is gx. We can cancelling ln and e. E to the power ln gx is equal gx by cancelling e with ln. Example number 7. Find the domain and the range of the function fx is equal ln of 2x minus 4. To find the domain, take 2x minus 4 bigger than 0. Then, taking minus 4 from left to the right, then 2x is bigger than 4. By dividing by 2, then x is bigger than 2. Therefore, the domain is from 2 to the positive infinity, and the range is all real number, as shown in the graph of the function. The domain is bigger than 2, and the range is all real number. Example number 8. Find the domain and the range of a function fx equal ln of 2 over x minus 1. Take 2 over x minus 1 bigger than 0. 2 over x minus 1 is bigger than 0 if x minus 1 is bigger than 0. By taking minus 1 from left to the right, then x is bigger than 1. Therefore, the domain is from 1 to the positive infinity, and the range is all real number, as shown in the graph of the function. Domain bigger than 1 and range all real number. Example number 9. Find the domain and the range of the function fx equal ln of square root of x minus 1. We must take x minus 1 bigger than 0, taking minus 1 from left to right, then x is bigger than 1. Therefore, domain is 1 to the positive infinity, and range is all real number, as shown in this graph. Example number 10. Find the domain and the range of the function fx equal ln of e to the power x square minus 1. First of all, f of x equal ln of e to the power x square plus 1. Fx equal ln of e to power x square plus 1. Cancelling ln with e, then x square plus 1. This is a polynomial function, therefore the domain is all real number. To finding the range, we take it before we must find the vertex of this function, because we haven't x with the power 1, therefore the x is 0, x is 0. By replacing or finding y here, then g of 0 is 0 square plus 1 is 1. Therefore, the vertex is 0, 1. And the range is from 1 to the positive infinity. And the range of g f of x from 1 to the positive infinity, as shown in the graph. Domain is all real number, and the range is from 1 to the positive infinity. Example number 11. Find the domain and the range of a function fx equal e to the power ln x plus 1. Fx equal to e to the power ln of x plus 1. By cancelling ln and e, then fx is equal x plus 1. Because this function is first degree, therefore the domain and the range are R, or real number, because it is a line. Here we came to the end of the video. Please share it with your friends so that everyone can benefit. Please write your comment and subscribe to the page, and also like and ring the bell. Thank you for watching, and goodbye.